equation is 64x to the power of 1 over 8 times y to the power of 7 over 8 equals 9500. The first part of our problem is to find the derivative, and you should do that by using this formula. So, Alessandro, could you do me a favor and please come out and solve it with this formula? Thank you.
Okay. Good luck, bro. Thanks. Okay, so for the first step, we have to find f in terms of x. So and for the second part of the equation, we have to find f in terms of y. And then after we find both of these, we have to plug them into the equation, which would be 8x negative 7, 8, y 7, 8 over 56 x to the 1/8 over y to the negative 1/8. Okay, so after this step, we have to simplify the equation. So you can see here, we can simplify these. This becomes 1, this becomes a 7. And since this is a negative, this is a negative, we switch their places in order to make them positive. So in the end, this would be negative. So y 7, 8. 7 x to the 1/8, x to the 7, 8, and these just add up to 1, and so does that. So this is just y over 7x.
Thank you very much. Well done, Alessandro. However, some of your classmates asked me how we actually got this formula here, so I'm going to explain it. So this formula is the simplified version of this one, which is df over dx terms of x and y equals df over dx times dx over dx, which is 1, we'll see that later, plus df over dy times dy over dx, which is equal to 0. So as I said before, dx over dx is 1, so we can cancel that out. And then we can take this df over dx and put it on the other side of the equation. So we will have df over dy times dy over dx equals minus df over dx. And then, because we only need this dy over dx, we will divide this part of the equation by df over dy. So it's going to be like this. And this here minus df over dx divided by df over dy equals this, because it's df in terms of dx. So yes, this is how we get this formula. So in conclusion, we can say that dy over dx equals minus the derivative of the function f in terms of x over the derivative of the function f in terms of y, which we can also write in this way. So minus fx, so the derivative of function x in terms of x, divided by derivative of function f in terms of y. So here. Alright guys, now that I explained you how to get this formula, that dy over dx equals minus fx over fy, I have to ask one of you, I think Stefan, to come outside and explain us please how to find the marginal rate of substitution at x equals 92 and y equals 362.
Alright, yeah, sure. Good luck. Thanks, colleague. Okay, so since this time we're dealing with a rate, this formula is actually going to become positive because a rate can never be negative. And so this answer we got for the last question would become y over 7x, and then we just substitute the numbers, which would become 362 times over 7 times 92, which is 644. And if you do that, it would become around 0.56, which is our marginal rate of substitution. So every time a unit needs to be substituted, it will go at this rate.
Alright, well done Stefan, you did very well.
Thank you.
So to summarize everything, firstly for the first problem, we have to find the derivative in terms of x and the derivative in terms of y. Put them both in this formula, so minus derivative of in terms of x over derivative of the function in terms of y, which then will result into our slope of the function, which we got here. And this is a implicit differentiation. And then secondly, we will use this result that we got from the first problem, substitute these two numbers in it, and then we got the marginal rate of substitution, how Stefan already did. Thank you very much.